Okay, in this video we're going to be looking at solving rational equations. So we've already talked about how to multiply and divide rational expressions, how to add and subtract rational expressions. Here we're going to be solving rational equations. So you're actually going to see that they're going to have an equal sign in them because they're an equation. Now this is going to look very similar to when you were in Algebra 1 and you were solving a proportion. A proportion is when you have a fraction set equal to another fraction. And so to solve a proportion, we do that by cross multiplying. So that's essentially what we're going to do here. We're going to cross multiply this direction, but because I have two terms down here, I have a binomial in my denominator, as this 9 comes down here to cross multiply, he's going to have to multiply to both terms that are down there in that denominator. And so I'm going to end up having 9x plus 9 from essentially distributing that 9. And as I cross multiply this way, same kind of thing, okay? The 3 is going to distribute and multiply to both parts that are down there in my denominator. And so I get 12x plus 15. Now at this point this is going to work just like solving a regular equation, like we're back in Algebra 1. We want to get our x's together. And then isolate our variable x. So I would subtract 15, divide by 3, and I would get x equals -2 as my solution to this rational equation. This one's going to work the same way. I'm going to cross multiply. As we distribute the 1, though, when you multiply something times 1, that doesn't really change anything, and so I have 11x plus 8 equals, now here since I'm distributing a variable, some interesting stuff is going to happen here. Okay, so x times 2x is going to give me 2x squared and 5x. Now at this point, because I have an x squared and an x, I know that I'm going to be setting this up as a trinomial, and so I'm going to end up factoring here. So I know that I need to make my 11x come over as well as my 8 so that I have 0 on this side here. So I have 2x squared minus 6x minus 8. And here we're going to have to solve this by factoring because there's no way I can isolate this variable here. So as far as factoring goes, you would need to be able to recognize that we can pull out a greatest common factor of 2. Okay, and then we need to say, can we factor more? And we would say yes. We would ask ourselves what multiplies to -4 but adds to the -3 in the middle. And hopefully everyone's okay, with that would be a -4 and a +1. And remember, we would say, now take this little factor here and set him equal to 0 and solve that little baby equation. So we get 4, and then we would say take this little factor here and set him equal to 0 and solve that little equation, and we would get -1. So if you have an x squared and an x term, you've got to solve him by factoring and then take each of your factors, set those equal to 0 to get your actual solutions there. These two problems are going to work the same way, so feel free to pause the video here and try these on your own. And then as you resume the video, I'll show you how to work them out so you can check your answers. But we're just going to cross multiply here, distributing the 3 as we go. So 3x minus 21. And then I'm going to cross multiply. Now, please recognize that this is one term. There's no plus or minus sign separating those into two terms. So it's just 2 times 5x gives me 10x. And we just solve this like back when we were in Algebra 1. Getting our x's together first gives me 7x equals -21. Divide by 7, and we get x equals -3. Here we're going to distribute. Be careful that you are distributing a -4. So -4x, negative times a negative makes a +12. Distributing the 5, we get 5x plus 15. I'm going to add the 4x to move him over. Gives me 9x. Subtract the 15. Oops. Now, be careful here. Sorry. This is -3. I'm going to divide by 9. And this answer is not going to be -3, okay? This is -3 divided by 9, which is going to say a fraction. It will reduce to 1/3, but please understand why that is not the number -3, because of the bigger numbers on the denominator, so it's going to stay a fraction, okay? Now, understand that the ones we just did were one single fraction on either side of the equal sign. If we look at these have two fractions on the left-hand side. So they're going to have a different process, and we have to use what's called the LCD, the least common denominator. So the least common denominator for this one would be 4x. Borrowing the 4 from this denominator and borrowing the x from these two had the same. Okay, so the least common denominator is 4x. So what I'm going to do is I'm going to multiply this side by the LCD, the 4x, and whenever I do to one side, I have to do to the other side. So I'm going to multiply this side by 4x also. And since there's two things here on this side, I have to distribute him to both of those parts. So I'm going to have 4x multiplying times the 5 over his original denominator, which was x. I'm going to distribute to the 7 and have 4x times the 7 over his original denominator, which was 4. And then here I'm going to have a -9 multiplying times 4x over his original denominator, which was x. Now the reason I do this is because everybody's dating here, nobody's married, so the x's are allowed to cancel. These 4's are allowed to cancel, and these x's are allowed to cancel. So what I just did was eliminated my denominator so that I have no fractions anymore and it's regular numbers. 4 times 5 is 20. 7x, -36. And I'm going to just solve this for x. I have no fractions to deal with anymore, just regular nice numbers. So it gives me -56. I would divide by 7, and I would get -8. This one's going to work the same way. So here our least common denominator would be 5x, borrowing the 5 from him and the x from these two were both denominators of x. I'm going to multiply both sides by that least common denominator, and the reason I'm doing that is to cancel out my denominators. So I'm going to have to distribute, multiplying the whole side times the 5x. I get 15 times 5x over the original denominator. I get 4 times the 5x over his original denominator, and I get 7 times 5x over his original denominator. The x's will cancel, the 5's will cancel, the x's will cancel, and I'm left with, what is that, 75, I believe, 4x, 35. We would subtract the 75 and get -40. Goodness, sorry. We would divide by 4, and we would get the x equals -10 for our solution there. All right, so these were considered the easy level. In class we'll practice and learn how to do the harder level ones.